What can you tell me about the atom on the left? This is a before and after scenario I'm going to show you. Tell me about the atom on the left and its valence shell.
Has 7 valence electrons.
And in order to be content or stable, it needs, just say it, 8. And this atom over here has 2. And it's stable at 2, but its outer shell has
1.
and really it needs how many to be stable? 7. So the likely scenario is this atom is going to release an electron. What just happened between those atoms? If an atom released an electron to another atom.
Ionic bonding.
In this case, it's an ionic bonding. How do you know it's ionic? Because it took an electron. What happens to the atom that took the electron? It negatively charged. So the atom to the left becomes negatively charged and the atom to the right becomes positive. Great. Scenario number 1. So scenario number 2. Here is the start. I've got atom on the left and atom on the right. I'm going to take this atom and I'm going to do this. Hold on, because I got to make this correct. And I'm going to do this. What happened now? Who could tell me? It's a covalent bond. How do we know this? Because they're sharing electrons. Okay? What happens if I do this? Who could tell me? They're sharing electrons unevenly. What do we know about that? Unevenly. Yes.
It's called a polar covalent.
It's called a polar covalent bond. Okay? We know they're sharing electrons unevenly because there's a charge on each side of the atoms. Who generally is taking, which atom? Atom left or atom right is taking the electron or pulling harder? Why the left one?
Because it has more electrons.
They are sharing electrons. So who is pulling?
Oh, the left one because it's negative.
The left one because it became negatively charged. So when you take or when you're pulling harder, you become negatively charged. Okay, so that's polar covalent bonds. The charge generally goes on the outside because that's where the pull is taking place, right? All right, so we're going to move on. Yes. All right, so we're going to study, now that we know about bonds, we're going to study about inorganic compounds of life and organic compounds of life. So who can tell me the chemical makeup or what elements make up water? Hydrogen and oxygen. How many?
2 hydrogen.
2 hydrogens and 1 oxygen. Good. H2O. Have you ever thought of this? 70% of Earth is water and 70% of you is water?
What?
Yeah. You're balanced with your environment because your body is trying to maintain a balance with its external. Just like your cells do, and we're going to learn about that, you do as well, or all organisms. Now, water shares electrons, or hydrogen shares electrons with oxygen, but notice what's happening here, right? So who could tell me what type of bond water forms when it combines its hydrogen and oxygen?
Polar covalent bond.
How do you know that?
Because there's charges.
Because there's charges. So they're sharing electrons, but they're sharing them unevenly, and there should probably be like a negative charge up here because the positive charge is on the hydrogen end, okay? There is this unique force that occurs between these hydrogens. So the hydrogens are not bonding, right? Because what's bonding? Hydrogen with what? Oxygen. But there's this force between the hydrogens, almost like they want to bond, and it causes these properties that water has that are unique to most compounds on Earth or in life. So here you have an oxygen and 2 hydrogens. What about out here? What's this red?
Oxygen?
Look at it.
Oh, no.
Yeah,
That's oxygen.
Look at it. Oh, yes, I'm sorry. Oxygen. You're looking good. What are the blues? Hydrogen, and they make, when they combine, H2O. Okay, good. Sorry, I wasn't looking. All right, so back to that force or that magnet between the hydrogens causes all these unique properties of water. Looking at the pictures, who can give me any of these properties?
Can you go back?
Yep. Go for it.
A solid.
A solid. It could exist as a solid or gas. So that's a unique property to water. Anything else on this page you can give me?
Plasma.
Yes. So its states are found, and this is the only compound.
Has a high, I think freezing point. No, I mean boiling point and low freezing.
Awesome. If you look at the thermometer, when you boil water, it boils at 100, and when you freeze water, it freezes at 0. So it's the only one that has the extremes on the temperature scale. Yes.
Universal solvent, which means it mixes with most substances.
Or does more than mix. What does it do?
Combines.
Better than combines. Dissolves. Good. It dissolves most substance. In this class, whenever we refer to a solvent, we're going to refer to water unless I tell you something differently. Water will always be our solvent. Water dissolves most substances. Even in our atmosphere, when it rains, most chemicals that are in the atmosphere will react with water in some way. Some more properties. Look at this diagram. And honestly, this could be a test question. I could give you that diagram and say, look at the diagram of water and look at the diagram of what water releases or breaks apart into. What would you tell me it does? It breaks apart into what?
Solvent and a solute.
Nope. Yes.
A hydrogen and an oxygen and a hydrogen.
Good. A hydrogen ion and an OH, which you don't know what the compound is called, but it's called hydroxide. So water is the only substance that breaks apart into equal amounts of hydrogen ion and equal amounts of hydroxide. And that gives it a pH of what? Does anybody know what pure water's pH would be? 7. It's neutral pH because of this. Now look at this diagram. What's the word that's missing there? If water is here compared to all others, what can you tell me about its specific heat? Look at that graph. So if I give you this graph and I give you that statement and I tell you fill in the statement by looking at the graph, the only answer here is it's higher. Water specific heat. See the title of this? Some specific heats, and water has the highest. So you're going to fill in the blanks. Yes.
Why is it?
Thank you for noticing the typo. This should be OH negative. As it is hydroxide ion, and it's always a negative charge. Now the last one. Water has high surface tension, which, do you see how my water molecules are kind of clumping together?
Yes.
That basically what it means is that it makes it sticky. Have you ever done the lab where you put water on a penny and all the drops kind of mesh together? Or forget about a lab. You went to a restaurant and the water spilled and all the drops end up forming like a little puddle. It's like they find each other. That's what it's saying. They connect. Okay, they clump together. And that allows for organisms to be able to walk on water. We can't, but. Water breaks apart and releases equal amounts of hydrogen and hydroxide ions. Other substances don't do that. When they are dissolved in water, they produce uneven amounts of these ions. So this creates their what? What am I referencing here? pH. And we call that the power of hydrogen because hydrogen's released in some capacity and it gives it a specific level on the pH scale. So we know that this 7 is what? Neutral, which is what? No, neutral, which is what? What is the only neutral? Water. Water is my only neutral substance. It's the only molecule or compound that has a pH of 7 when it's pure, which means it produces equal amounts of OH and H. What about this side of the pH scale? So we're going to say 7.001 and on.
Is it acid?
Nope,
Base.
it's a base. So it's a base, and what I want you to know about bases is that they produce more hydroxide ions.
Oh, I was right.
I just flipped it over. Do you notice that?
Yeah.
Yeah. What about 0 through 6.99999? It's an acid. And here, what do you think we're going to produce more of? Hydrogen ions. Good. Because if bases produce more hydroxide ions, acids will produce more hydrogen ions.